aim of this experiment is to compare the theoretical mass and the experimental mass of magnesium oxide produced when magnesium is burnt in air, and determine the percentage yield of the reaction. We're going to do this by using stoichiometry and performing the physical experiment, then comparing the data recorded. Stoichiometry is the part of chemistry that studies amounts of substances that are involved in a chemical reaction. You might be looking at the amount of substances before the reaction. You might be looking at the amount of material that is produced by the reaction, but overall, stoichiometry is the math behind most chemical reactions. Now, we're going to use stoichiometry to calculate the weight of oxygen in this equation. First of all, we'll write down the equation. Magnesium, after the reaction takes place, this now becomes magnesium oxide. We already know the weight of magnesium. It was 0.2 grams. We can now go and divide this by the atomic mass of magnesium. This will give us the amount of moles, okay, and now this equals 0.0083. We know that this equation is balanced, so that would mean that oxygen is also 0.0083 moles. We can rearrange the equation in form of the oxygen, so that would be X being the number of grams in the equation divided by the atomic mass of oxygen, which is 16, will give you the number of moles of oxygen, which you already know, which is this number here. Now we can rearrange this, so it will be X equals 0.0083 multiplied by 16, which gives you the total weight of 0.133 grams. Now if you add the weight of magnesium, 0.33, now you will get it. This is the total weight of the compound magnesium oxide. Now that we have done the reaction formula, we now know that the weight of magnesium oxide is 0.333 grams. We are now going to do the physical component of this and do the experiment and compare our findings. First of all, you're going to want to weigh the crucible and lid. For us, that was 30.57 grams. Then, you're going to want to weigh your magnesium ribbon. For us, that was 0.2 grams. Now you add these together, this will give you a total weight. Okay, to set up the experiment, you're going to need all the equipment that is required, being a tripod, Bunsen burner, clay triangle to place the cradle and lid, like this, and of course the magnesium and sandpaper. You're going to start by grabbing your magnesium and rubbing the sandpaper across it. This will stop oxidization happening on the magnesium ribbon. Then you're going to scrunch it up into a little circle so it's able to fit in the cradle. Once you've placed it in there, you're going to want to make sure it's directly over the flame. and then grab something to ignite the flame. Once you find something to ignite the flame, you're going to want to turn on your gas and light the flame. Put it on your safety flame first so you can see when it's been ignited. Place the Bunsen burner underneath the pot and wait until a reaction starts to occur. You'll know when the reaction occurs because the magnesium ribbon will start to smoke. Once your magnesium ribbon starts to smoke, you're going to want to place the lid over the top.
The reaction is now starting to take place as it is smoking. Occasionally lift up the lid to bring oxygen into the reaction.
You will see when the reaction is stopped, as the flame will go out and the magnesium will stop smoking. When this happens, turn off the flame and let the crucible cool. Once the crucible and lid have cooled, you can place it back on the weighing scales. Before the reaction, the crucible lid and magnesium weighed 30.77 grams. Now the crucible lid and magnesium oxide weigh 30.85 grams, a total of 0.08 grams increase. The magnesium went from 0.2 grams to magnesium oxide weighing 0.28 grams, a total of a 40% increase. The increase was less than the theoretical increase, which would have been from 0.2 grams to 0.333 grams, done in the mole calculation. Many factors go into play when doing this, as in the actual physical practical, some of the dense white smoke could have escaped from the crucible when burning. We could have had an issue with incorrect weighing, or maybe the mass of magnesium will be too low if the magnesium metal does not combust, meaning we didn't melt all the magnesium in the crucible. The experiment was still a success, as it demonstrated that after the chemical reaction of burning magnesium and forming magnesium oxide product, there is an increase of mass.